All right, hello and welcome. It's been a little bit, but I'm hoping to make some more videos now as we get kind of through the meat of the season. Um, my intent with the next few videos is basically to walk through the process of designing a robot for this year's game. We're going to design a robot in the style that 2220 has designed our robot. Um, with some changes. It's not going to be exactly the same robot. We'll use some of the lessons that we used building our robot this year. Um, and hopefully it's going to be an interesting series. So, for this first episode, what our goal is going to be is to get through kind of the overall way that we design robots on 2220 and also just quickly lay out something similar to our drivetrain. So, let's start out. So you'll notice that I'm starting with this document main sketch example, and we're just going to start with sketches. Nothing too whack about that. We are going to be doing something a little bit careful. You might have seen this in some other videos, but what we're going to do is basically design the entire robot in sketches and then use those sketches to create our various sub-assemblies. So we're going to start with the side profile. We're going to start with the side profile for a very important reason. You kind of end up with two key profiles for a what's the term, drivetrain. You kind of end up with the side and the top. They're both important, but kind of we'll start with the side because that'll define this distance of how far we are off the ground, which this year we're designing using Swerve Drive Systems modules. And I happen to know that this distance is about 1.75 for these, and then we end up about a quarter inch from the edge. This isn't exactly right, but it's good enough for our purposes here. And it's approximately what will line up with a CAD model. So with a CAD model for those things. So we're going to do a little bit of mirroring here. And then we're going to add just a box up here. This box is going to be, well, we'll play with it a little bit. If I remember correctly, it's something like this, but the goal of this is to kind of reserve the space for the swerve modules. So I kind of leave it like this, just kind of a reference. We'll kind of go back and change that once we're through there. So we'll name that the drivetrain side, and that's cool. We have a few other things that we're going to want to do here. So from there, we'll go and define a plane that is going to be kind of defined by the midplane of this. And that'll let us use this at exactly the level that it needs to be used. So up just like that. And then we're going to use a few tools to kind of make sure that this all lines up. So we're going to want each of those end bits. And then we know that we want to be something like this. Those were already constrained. Of course they were. Okay, we're going to be 24 inches wide, and we already defined that it's 26 inches long. One of the bits that we'll need to do here is kind of cut these off. You can also do this with the with just like making another rectangle. I like to do it like this just for personal reasons, just personal preference. So this is kind of the core So that's going to be the drivetrain top. And I'm going to leave it this one like this. We actually are going to do another sketch that's basically going to be the these drivetrain cross members. So these are kind of important. And then it's going to be like 10 inches, which I think these 5 inches there, which is what we want. Cool. So I'm splitting this up into a whole bunch of different sketches for a few reasons. The more granular this is, the easier it is to change one thing without breaking everything else. Also, it's easier to kind of cascade failures, but you can, if you're careful about how you're referencing these things, you can kind of avoid that. So we're going to create a folder. It's going to be Drivetrain. And we'll just really quick design that. All right, and so I'm not going to actually go immediately into a sketch. I just did kind of instinctively, but we're not going to. What we're going to do is we're going to derive all of these sketches. And the nice bit about doing it like this is that now we can just extrude individual all of these. So if you haven't seen the extrude individual feature script, that's Julia's feature script. I'll throw it in the link for the video, and hopefully you'll find that useful. So this is right. So we've got this. This is kind of the body of each of those, which is cool. We're going to need to do a few things before we go on. So one of those things is that the way that 2220 wires our robot, and you'll see this when I pull it in, is we have kind of a control board that's in here, and then we like to kind of run things through the tubes. So what I'll do is throw in some holes here that can be used to represent those. These are going to be 1.5-inch holes. And actually, I just realized that I messed up this. So instead of doing all of these at once, what we'll actually just do is half of it, and then we'll mirror everything. And by doing that, we kind of make it easier for ourselves because we don't have to replicate the features everywhere. So we'll get back into there. So the exact position of these, because we haven't fixed down a lot of things about the design, isn't super important. It obviously it will matter more later. So I'm going to offset those by about 2 inches. The goal is to leave that there a little bit of space here for us to have tube plugs that go in there. And those aren't going to be totally unpatterned, but that's all right. And just take those, and those are going to be half depth because we're going to have a swerve module right here, so we don't want to wire directly through that. That would be a little bit of a pain. So instead of doing that, what we'll do is throw them kind of in the middle-ish. Just put those like 7 inches in. We'll probably come back and visit these later. All right. Half-inch, and they're not going to be all the way through either. So we got those. I'm going to go through and I'm going to name all these features. Right. So, and I think that that's basically all of the features that we're going to want on these before we get anywhere. So I will take tube converter, just another Julia thing. You notice it doesn't currently have any holes, so we'll have to add those. And that'll look something like that. And I might increase that margin offset because I don't like having holes that close. So you can tell I have not built this exact part before because I don't know exactly what the but oh wait a minute. I'm doing the wrong thing, aren't I? This is what we actually wanted. It's the whole margin. So margin offset is offset from the end. Margin is the margin around the holes. Usually it isn't more than 1/16 of an inch for something that close. There you go. So you can see that those holes kind of just disappeared, which is what we want to see. I'll just leave that as a tube converter. So we're probably going to have a few other things that we want to do here. So one of those is going to be, so we will want some holes here. We can just make those nice and big. Technically, a socket clearance is way less than 1/2 of an inch, but I just like to make it 1/2 an inch, and then it's a little bit easier to get at things. So we've got those. We could do ones at the end, but I kind of go back and forth between whether I like them, so I'm not going to. We didn't do it on our 2022 robot, so we're up to next, sorry. So why did you not like that? Okay. Up the face. There you go. Clearance, so it's not clearance holes. There we go. All right, so we've got these kind of center rails. We've got some end rails. I don't have an extra hole in here. You could technically do a middle hole. The West Coast Products 2 plugs that we used for this do, but we're not going to. All right, so that's kind of the core things with the tubes. We might also have some other clearance holes that we add later, but we won't worry about those at this exact moment. So kind of one of the next bits that we want, sorry, I'm flipping around, is going to be like this. And so I do them like that. I do it like this basically because I like to have a little bit of an offset from the edge. So um, having an offset from the edge kind of saves you from some mistakes that you can end up with. If I remember correctly, the what are they called again? The storage drive systems modules start, their first hole is the fifth one in, so this guy. But that's not 100% relevant right now. So it's the fifth one, and then it's basically every inch. So 1, 2, 3, 4, like that. So what we'll actually do here is I will actually, this can't just be construction. We're just going to use a whole bunch of these to make the initial one all the ones we think we're going to need. And that'll be, I like to go 0.24. That means that if I do 0.24 on each side, I have a nice little itty bitty gap there that makes all the clearances work out. And this will be just a little bit from the edge. Okay, and we can see that we're kind of doing the same thing down here. And you see that we're pretty close to the same. So that one's actually probably the right hole here. All right, so we kind of have the base of that gusset, which looks something like that. 2220 would make this out a 0.09 inch gusset. We'll rename some of these guys. It's always good to name things as you go. Helps make sure you can view things later, remember what they are. If these were more than like 2, and even if this got larger, I would probably group these up into folders just to shrink it down. But they're not, so I'm not going to do that. I just realized I should probably also have one of these guys right here. That the reason for that one is that makes this a symmetric. That will make this a symmetric part, which is very nice. Oh, that was the wrong one. So there we go. All right. So we've got those. So then the big deal is, this could be fine. This would be a fine part if we were going to stick a bolt all the way through it with the 1032s. But for us, we're just going to, what we actually want to do is use a shorter bolt. So we'll do that. So I think it's 1, 2, 3, 4, 5. And this will be a 0.5 inch. And then what I'm going to do is I'm going to, I'm going to do it like this. And the reason I'm going to do it like this is because doing it with a pattern like this will make it easier to change if I want to make this a little bit different later. You notice this guy kind of hangs off the side. That's not ideal. But we'll kind of we'll live with it. We'd probably want to trim that off, and we probably will. So we got that side, and then the other bit that we'll do here is we'll create a little line here and use that to mirror across, because these are going to be symmetric across that. And you can see that now we end up with basically the same thing here. And I'm going to go into an extrude, and we're going to remove. And we also want to remove from both of these. And you'll notice that right now it's just doing this corner. What we'll also do is we'll mirror these across to make sure that they're all good. Make sure that we're fine on all sides. So we're going to go up to that face, and now you can see we've got some nice clearance holes. Yeah, so our other option is that these don't need to be 1/2 inch. If they were something closer to what's actually recommended, which is like 3/8 of an inch, we end up with that. And in fact, I'm probably going to do that just because that's a little bit nicer. And then we're going to do our mirrors. So mirror those across. And you see that now we get those down here. Mirror them down here. Then we'll name these clearance. Right. And kind of our final bits, we're just gonna round everything off. Not the entire corner, that would be bad. And I'm just gonna do those outside ones because I want to do something a bit larger on the this inside. Something more like yeah, maybe a 1.5 inch. Just give it that little bit of extra strength down there. All right, so we've got that done. Which means that all that's really left to do is mirror this around. So my philosophy has changed a little bit since the last time we talked. And honestly, I just like mirroring things now. I like not having to do very much assembly at all. And so we're going to mirror these across. We're going to make sure that they're new. And then we're going to mirror this guy to the back. And now we have all of our different parts. This is the bottom gusset. All right. So we could technically mirror this guy too, but it's a little bit less painful to just use that one, so I'm not going to. We're going to assemble the drivetrain, and then that'll be it for this video. All right. So we're just going to insert the whole thing, group it all up, and then fix it. So one of the things about doing this way that I will note is that if I go back to before my mirrors, this guy's going to be broken. So you got to be careful about the state of that when you do this. Splitting it into separate documents can also help with this, but we haven't done that yet. So, all right, so we got all of our gussets, and then we're just gonna take this guy and do it a few times. And this could be like, there are different ways you could do this. Like I could do this as a radial pattern technically if I made a helper part in the middle. I just don't personally like to do that. Like if it was something that wasn't just like a single gusset, I might do it, but this is a gusset. It's not a big deal. All right, so we've got kind of some of our core stuff, and then we're going to go and insert some things from MKCAD. We like swerve drive here. So we like the Mark IV. Now we're going to use this in the same configuration that I used it, that we used it with 2220, which is like this. And we'll see if I got my spacing all right. Assuming on shape is entirely cooperative. 2, 3, 4, 5. Yep. So just like that. 3, 4, 5. Two, 3, 4, 5. So now we've got effectively a drivetrain. It's missing some fasteners, but that's all right. We'll be able to get to that point soon enough. We're also missing the tube plugs, so I'm going to add those, and then we'll call it. So where those live, so those are a 2220 thing. And these are, I believe, released publicly. If they aren't, I'll make sure that they are by the time this video comes out. Tube thickness is going to be a 1/16 of an inch. So we got one of those. 2, 3, 4. And then these are just kind of nice. Just plug them in there. And then get them to look right. So those come in with all the fasteners as I've catted them, but that does not necessarily mean that you use all the fasteners. There's an option to just not have them. I just tend to leave it on so I can see where those would be if we were to have all of them. Oh, I accidentally said that. Great. And I just accidentally went too far. There we go. And thinking about it for a little bit. And I think I got to do, yeah, 2 more. Great. I'm just not going to throw in those fasteners right now. We will leave it at that. So we got that guy, and then we're going to bring it back in to a full robot. And one of the things that we're also going to do here, while we're at it, is since we're using all a constant reference frame, I'm going to add a mate connector. It's going to be there, and it's going to be right here. Then when I come in here, you can see that that's visible. And then when I insert this, I will be able, when I get back over to my current document, I'll be able to throw this guy in. And then just fasten this. right there. All right, and that's where we'll leave it for today. So this is the document thumbnail. And that'll be that. Hope to see you next time. Have a good one, and good luck this season.